Hello out there, welcome to this tutorial on the cuboid. In this video, we'll be looking at properties, net, surface area, volume, and capacity of a cuboid. So we take the first item, properties of a cuboid. A cuboid is a three-dimensional solid shape. It has 6 rectangular faces. It has 8 vertices. It has 12 edges and it has 2 planes of symmetry. So we look at the diagram of a cuboid here. This is the edge, the straight line, the straight side is the edge of the cuboid. And we have this, the bottom, the left side to be the rectangular face. That's one of the rectangular faces, and where 2 or 3 lines meet here is the vertex, and you can see 1 2 3 4 5 6 7 8 vertices. So we have 8 vertices. And when we talk of plane of symmetry, that is the line, when you cut this, it divides the shape into 2 equal cuboids. When you draw a line or cut it this way, it also divides the shape into 2 equal cuboids. So we refer to these as planes of symmetry. Then we go to the next item, the net of a cuboid. If a cuboid is dismantled and separated into its component, we have 6 rectangles from the rectangular faces. This is shown in the diagram below. This is the net of a cuboid. These are the 2 opposite faces, left and right, and these are the 2 opposite faces, the one for the back and the front. This is the bottom rectangle and this is the top rectangular face. And we go to the next item, surface area of a cuboid. Given the cuboid below with length L units, breadth B unit, and height H units, this is the length, this is the breadth, that's the bottom rectangle, and this is the height. So we look at the area of the top and the bottom faces. The area of the top and the bottom faces, since they are rectangle, so we have it length times breadth here, and also length times breadth here. So that's going to be LB plus LB. We have it as 2LB. And the area of the left and the right faces, this is the left face and this is the right face here. We have B times H, that is the area of the rectangle there. Then also this is B times H. So we have BH here plus BH here will give us 2BH, and the area of the front and the back faces, the front, that is the length and the height and the length. So the area here will be length times height plus length times height. That will give us 2LH. So that the total surface area of the cuboid will be 2LB plus 2BH plus 2LH. And since 2 is common to them, we can factor out 2, so that we have 2 into LB plus BH plus LH. And that is the total surface area of the cuboid. Then we go to the next item, volume and capacity of a cuboid. So we still consider the same cuboid with length L unit, breadth B unit, and the height H unit. The volume of the cuboid will be base area times height, and the base area is length times breadth, then multiply by height we have the volume to be lbh. And for the capacity of a cuboid, we say in our previous videos on other solid shapes, we said the capacity can be in cubic meters or cubic centimeters. So if it is in cubic meters, we have it divided by 1000 liters, and if it is in cubic meters, we have it multiplied by 1000 liters. And we have taken care of all the items. Now we look at some problems involving the volume, surface area, and capacity of a cuboid. So we take our first problem. Problem 1. Calculate the A, total surface area, B, volume of the cuboid below. So for the A part of the problem, we have to calculate the total surface area, and we know the formula is 2 into LB plus BH plus LH, and our L is 12 centimeters, our B is 8 centimeters, and our H is 10 centimeters. So substituting into this formula, we have it as 2 into 12 times 8, and plus 8 times 10, then plus 12 times 10. This gives 2 into 96 plus 80 plus 120. Remember, we are observing body mass here. It is not 12 times 8, which gives 96, then plus 8 before you multiply by 10. We have to take note of that. So we simplify all the multiplications first, then before the additions. So we add this and multiply by 2. That will be 2 into 296, which gives 592 squared centimeters. And that represents the total surface area of this cuboid. And we go for the volume of the cuboid. The volume of the cuboid is said to be length times breadth times height, and that gives 12 times 8 times 10. 12 times 8 is 96 times 10 is 960 cubic centimeters, which gives the volume of the cuboid represented in problem 1, which brings the solution of the problem to an end. We go to the next problem. Problem 2. A wooden rectangular box has its dimensions as 0.5 meters by 3 centimeters by 0.7 meters. Calculate the volume of the box in A, cubic centimeters, B, cubic meters. In our solution, we know the volume is length times breadth times height. So starting from A, volume in cubic centimeters, meaning we are going to convert all the dimensions in meters to centimeters. So by multiplying by 100, 0.5 meters, multiplying it by 100, I have it as 50, multiply by 30, then multiply by 75, and 75 times 3 times 5, then add the 2 zeros. We have the volume to be 112,500 cubic centimeters. And for the B part, we don't need to convert this one to meters then multiply out. No, we can just express these cubic centimeters to cubic meters by dividing by 100 in 3 places, because we have cubic here. If it is squared, we just divide by 100 by 100. So 112,500 divided by 100 times 100 times 100. We have said it that since it is cubic, so it is dividing by 100 in 3 places. The 2 zeros here, we remove the 2 zeros. we'll be left with 4 zeros, 1, 2, 3, 4. So expressing 1125 as 4 decimal places, we have it as 0.1125 meters cube, and that gives the volume of the problem represented in problem 2 in cubic meters. So we have done justice to this problem. We go to problem 3. A concrete block is 20 centimeters long, 18 centimeters wide, and 40 centimeters high. Calculate the A, volume of the block in cubic centimeters, B, mass of the block in kilograms, if 1 cubic centimeter has a mass of 1.2 grams. So in our solution, we have to find the volume first, and we know volume is length times breadth times height, and that gives 20, which is the length, times 18, which is the breadth, times 40, which is the height. And this is 36 times 4. It's going as good as saying 72 times 2, which is 144. We add the 2 zeros, we have 14,400 cubic centimeters. We've done justice to problem 3a. We go to 3b. We said mass is volume times density, and our volume is 14,400 and the density is 1.2 grams. So we have 14,400 times 1.2, that gives 17,280 grams. Since we have to give our answer in kilograms, we divide by 1,000. That gives 17.28 kilograms. And that's the end of solution to problem 3. We go to problem 4. A fuel tank has internal dimensions as 50 centimeters by 40 centimeters by 20 centimeters. What is its capacity? And capacity is measured in liters. So we first calculate the volume, then convert the volume to capacity. So here is length times breadth times height, 50 times 40 times 20, and that will give us 40,000 cubic centimeters. And the capacity now will be volume in cubic centimeters divided by 1,000. That's 40,000 divided by 1,000 will give us 40 liters. And that's the capacity of the fuel tank with the given dimensions, 50 centimeters by 40 centimeters by 20 centimeters. So we have done justice to problem 4. We go to problem 5. Problem 5. A village water tank measures 5 meters by 4 meters by 6 meters. How many liters of water does it hold when full? B. How many days would a full tank last if consumption rate is 24,000 liters per day? Okay, here we need to calculate the volume. Then that's going to be in meters, multiply by 1,000 to give us the capacity in liters. Then we go to B. So for A, the volume is length times breadth times height, that is 5 times 4 times 6, which gives 120 cubic meters. And now we calculate the capacity. Since the volume is in meter cube, we multiply by 1,000. That's 120 times 1,000, which gives 120,000 liters. And that is the liters of water the tank can hold when full. Now we go to B. Since the consumption rate is 24,000 per day, So to get the number of days, it is 120 liters divided by 24,000. So the three zeros here cancel the three zeros here. 120 divided by 12 to 10 to, so we have it as 5 days. So it will take the village 5 days to finish using the water in the tank when it is full. That's reasonable. So we go for problem 6. Problem 6, 6.75 kiloliters of water is poured into a rectangular tank of square base 1.5 meters. What is the height of the water in the tank? So in our solution, we are given the capacity. We have to express it as first liters, since 1000 liters make 1 kiloliter. So first we say the capacity is 6.75 kiloliters, which is equal to 6.75 times 1000 liters, which gives 6750 liters. We have to convert it to volume in meter cube. Okay, it is meter cube because this one is given in meters. Now we divide by 1000. That is the liter divided by 1000. So that is 6750 divided by 1000 will give us 6.75 cubic meters. And then from here, we need to calculate the base area. Then from there, we'll be able to calculate height, since volume is base area times height. So the base area now will be 1.5 squared, since it is a square base, and that will give us 2.25 squared meters. And from here, the height of the water in the tank will be the volume divided by base, which is 6.75 divided by 2.25. Multiplied by 2 will give us 5.5. Multiplied by 3. If you multiply this by 3, we give 6.75. Therefore, 6.75 divided by 2.25 gives 3 meters. So the height of the water in the tank is 3 meters. So that's the end of solution to problem 6. We go to problem 7. A rectangular box has a volume of 140 cubic centimeters and height 2.5 centimeters. Calculate the base area of the box. Oh, that's very simple. So quickly find solution. We know volume is base area times height, so our base area now will be volume divided by height, which is 140 divided by 2.5, and that gives 56 squared centimeters. And that's the end of solution to problem 7, and this is the end of the road for this tutorial. I hope you enjoyed it. If you do, check the description section of this video on our YouTube channel for more videos on solid shapes with respect to surface area and volume. Please remember to like and share these videos. Until I come your way again, goodbye.